I'm going to go through the answers to the 2020 mock exam presented here, and in a separate video I'll talk about how you might consider scoring it. So first of all, you should of course read the question, read it closely, see what they're telling you. They've given you a graph, a histogram that looks like this, as well as some summary statistics. And basically this means there were 75 sections they looked at, and 50 some odd, 53 or 4 of them had between 0 and 2 trees, or 0 or 1 tree. And then this would be 2 and 3, 4 and 5, and up here at 14 and 15 for that number. So let's see how we would answer these questions. Letter A says describe the distribution of the number of dead trees. And so when we think this, we need to think about cussing it, or perhaps putting on the socks if that's the case. And so I'm going to talk about that, and then I'll write it down. The center is somewhere in here. It's very right skewed. This appears to be an unusual observation. And the spread is from 0 to 15. You could say that most of the data is down here with this outlier. So let's see how we could write that up. The distribution of dead trees in each section, always want to put it in context, is right skewed. It told me over here that the median was 1 and the mean was 2.36. You could list either one of those, especially since they've given it to you. So I would say the median is 1 tree. And I've chose the median personally because it's right skewed, and so that's perhaps a better representation. Where most of the data is from 0 trees to, what did it say? 0 trees to 9. 0 to 10 would be over here, so to 9. And I have an outlier at 14 or 15. 0 trees to 9 with an outlier at 14 or 15 dead trees. The standard deviation is 2.883 trees. I'm not totally excited about using standard deviation and median in the same paragraph right there, but I think I've covered everything. The center, the unusual observations, the shape, and the spread. That all looks good. Interpret the sample standard deviation S in context. Well, it's 2.883, and what that means is that the typical block has a difference of about 2.883 from the mean. Okay, so a typical block's dead trees is about 2.883 away from the mean of, what was that? 2.36. On average. Good, I've explained that in context. That's good. Name the sampling distribution used by this citizen to estimate the number of dead trees per home, and why is that practical? So I want to highlight a couple things here. This particular one, it says this: name the sampling method and describe why this is more practical compared to an SRS. Okay, so the sampling method he used was a cluster sample. And the nice thing about a cluster sample is that he didn't have to drive to a, a large number of these several thousand blocks. Instead, he was able to narrow his focus and be more efficient on the blocks that he was actually looking at. So let's see how I could write that down. This is a cluster sample, which is advantageous. I almost wrote nice, but advantageous is such a better word. Advantageous because once in a block, he can survey lots of homes. With an SRS, he would likely have to drive all over the city. Estimate the probability the randomly selected block will have less than 6 dead trees. All right, so what I don't want to do here is anything about a binomial or a normal distribution, because that's not what I have. I've got this distribution here. It said less than what? 6? So less than 6 dead trees means it's in one of these columns. And looks like, I don't know, this might be 5 and 8 and I don't know, 53, something like that. It's not super evident whether that's 8 or 7 or 6 or whether that's 52 or 53, and so that's okay. They're not going to nitpick you on that. And so it was said that there were 75 on here total. So the probability that I would get something less than 6 is going to be 53 plus 8 plus 5 out of 75. My guess is this year you could leave it exactly like that, or you could add it up. That's going to be, what is that, 66 over 75, or in fact, if you wanted to write that as a fraction, or as a decimal rather, I don't think there's any problem with that. That's 88 or 88%. So about 88% of the blocks have 6 or fewer dead trees on them. I like actually writing that sentence out. I think that's a good conclusion to that part. So I kind of did that over there. I won't write it again. So if there's 19 blocks with no dead trees, what's the estimated probability that if 4 blocks were chosen, these blocks would have at least 1 dead tree? Now, it doesn't say at least 1 dead tree each. Somewhere in those 4 blocks, we've got a dead tree. 19 of the blocks had no dead trees, which means if I look back here, out of this 53 that I wrote, 19 of them had no dead trees, and the others had 1 dead tree. And it says at least 1 dead tree, so it could be 2 or 3 or 4 or 5. And so there's a couple of ways to look at this problem. One of them is to say, look, if they're going to have at least 1 dead tree, I could also do 1 minus no dead trees. All right, well, what's the probability that there's no dead trees? So getting no dead trees, I'll do that in blue. Well, it's no dead trees. So that means the first one had no dead trees. The probability of that is 1975, 1975, 1975, 1975. And if I work that out, I get 1 minus 0.004, which means 0.996. Really good chance that there'll be a dead tree there. You could also use a binomial distribution on this to get the same answer. That would work fine as well. Letter F. We want to know about the conditions for inference here. It's a T confidence interval. And so we need to know, is it random? Is the 10% rule met? And do I have normality from large counts? Well, it is random. Yes, and I'm not going to write all this down, but yes, it was stated previously that we picked random blocks here. The 10% rule, yes, there's more than 750 or more than 10 times that number of blocks out here. And the normality, 75 blocks is big. It's bigger than 30 or 40, whatever standard you're using. And so all three of those conditions are met. I'd like to point out, I think a pitfall might be if you wanted to know if a tree is alive or dead, does that make it a binomial problem? Remember, I'm not asking trees, are you alive or dead? I'm asking city blocks, how many dead trees you have. So that's why it's a means problem and a t interval. So that was yes. I'll work the second question in a separate video.